Hi guys, welcome back to our lesson. So as I did say that we are still looking at the concept of solving questions under circle geometry, right? These are questions we adapted from past papers just to show you how do we apply these theorems. So let's just jump right into the next questions that we are going to try and do. So here they say M is the center of the circle SVQR. So that simply tells us that we are dealing with a cyclic quadrilateral because 4 points are on the circumference, right? You might think about it, although it might not be a four-sided shape, but if we have 4 points, then we can think about cyclic quad. Having equal chords, which is SV and QR, right? That tells us we can think about an isosceles triangle somewhere. Now what we know also is that RP is equals to QP, which RP and QP, I mean, are the tangents, not that they are equal, right? They are the tangents at R and Q respectively. And then lastly, we know that RPQ is equals to 70 degrees because of these tangents. Now, in a diagram, this is what our diagram will look like. Now, I just want to add a few things here, right? That PQ will be equals to PR because they are tangents from the same external point. Then telling us that angle R2 is equals to angle Q2, which because is an isosceles triangle. But remember, you don't say such things, right? You say angles opposite equal sides. And then even in the small shapes, we can talk about this being equals to that because it is the radii, and also that being equals to, I'm just going to erase one because they are all radii, so they are all equal to each other, not 3 lines. So all these lines are all equal to each other, but it doesn't tell us much about the angles maybe that we are dealing with there. Now, let me quickly add the information that we added, and then we will answer the questions. That's all that matters for now. Then the first question wants us to find the value of R2. Now to find R2, we know we're going to use the sum of angles in a triangle. Since R2 is equals to Q2, that will be then our starting point, right? So I will start by saying R2 is equals to Q2, and this is because it's angles opposite equal tangents, right? You will specifically say equal tangents. And then you will then say, we know that 2R2 plus 70 degrees must be equal to 180 degrees, which will be sum of angles in a triangle. Right? And therefore I will find my 2R2 to be equals to 180 minus 70, which will be 110 degrees. You divide both sides by 2, then R2 will then be equals to 55 degrees. And that's how you can find R2. So the first golden thing to think about here is what is the relationship of R2 with R1, because the only value I have is 70 degrees. And when I say I want the size, it means you must use the given value. So you can't go into any other shape other than this particular shape. Then also we need to find Q1. Now to find Q1, we know that this is going to be 55 degrees, we said, R2, and also Q2 will be 55 degrees. But we know that Q1 plus Q2 is 90 degrees. So that's where we're going to start. Q1 plus Q2 is equals to 90 degrees. My reason will be radius perpendicular to tangent. Please don't ever say Q1 plus 2 like this, because this simply means it's Q3. It has nothing to do with you adding Q1 and Q2, right? So these are just some of the mistakes that some people make based on just trying to shorten things and do things quicker, you see. So please make sure you are clear on that. Now we know we found Q2 based on this, right? So I will say Q1 will be plus 55 degrees, which is equals to 90 degrees. Then my Q1 will be equals to 90 degrees minus 55 degrees. Then Q1 will be equals to 35 degrees, right? So that's what we will then have as Q1. Now, to find M2, firstly, we need to find what M1 is, because that's the only angle we can find. The mistake that some people make, since all of these are radii, they then assume that these isosceles triangles, which is QMR, is the same as the isosceles triangle VSM, which is not the case. Yes, they have equal sides, but they are not necessarily the same thing. You can't use them across in that way, right? But what do we know in these two shapes? We know that equal chords subtend equal angles at the center. So this chord and that chord. Let me just erase the lines that we are not using so that it does not confuse you at the end of the day, right? Yes. So I know that those chords are equal, therefore they subtend equal angles. So if I find M2, if I find M1, then I know what M2 is. But please don't say it's vertically opposite, because they are not, right? So firstly, I will then say M1 plus Q1 plus R1 is equals to 180 degrees, right? This is just simply sum of angles in a triangle, right? Based on this, I will then say, but before I can claim this, I will firstly say Q1 is equals to R1, because this is angles opposite equal sides, right? Equal sides. And this will then be what I will use to try and find the value of M1, right? Because I know what Q1 is, which was 35. It also makes R1 to also be 35. Then I can find M1 based on that, right? So I will then say M1 will be equals to 180 degrees minus 35 minus 35 degrees, which will be the same as 110 degrees. So therefore, M2 will be equals to 110 degrees, and your reason will be equal chords subtend equal angles at the center. Right, so that's what we will then do. Guys, I'm just trying to shorten the reasons, but I hope you can then see them, right? And then also, they give us another shape now which has O being the center of the circle. CDE is a tangent to the circle. Guys, I won't lie to you. You see, I get very excited every time I see the word tangent, because there's a lot you can talk about when it comes to a tangent. There's a lot you can talk about when it comes to a center, you see. So these, I think, even a cyclic quad, those three terms are the ones that really excite me, especially when I'm doing circle geometry, because then I know there's a lot of things I can think about. Now, on this shape here, they told us that that is the center, which is O, CDE is the tangent, then BD bisects ABC, right? So BD bisects ABC, meaning B1 is equals to B2. They don't look like it. This is the emphasis of, because it looks like it, it does not make it what you think it is, unless you are told, you see. So no one can claim that these angles are equal by just looking at them, because they don't look like they are equal. But because I told you, then you can claim that they are equal. And then they firstly want us to prove why BC is parallel to OD, and they also do not look like they are parallel, right? What they want us to do here will be to either talk about an exterior angle of the shape, maybe, that we can try and talk about if there is an exterior angle, because that will lead us talking about either corresponding angles, alternate angles, not co-interior, because we don't have values, you see. So that's why I'm saying either you consider the exterior. And I can see that O1 is actually equals to B1 plus D2. Firstly, we know that B1 is X, right? So I will then quickly say B1 is equals to D1, and this is equals to X, and this will be angles opposite equal sides, right? And then I also know that O1 will be equals to 2x, right? This will be 2x. You can either say it's because of angle at the center twice angle at the circumference, or you can say exterior angle of a triangle, right? So it's an either or situation. It can be exterior angle of a triangle, or it can be angle at center twice the angle at the circumference. So please do consider those. And then from there, I know that it means that B is equals to B1 plus B2, which will be the same as 2x, and therefore I will then say that this is, the lines are parallel. BC is parallel to OD, and my reason for this will be converse corresponding angles. Converse corresponding angles, right? Converse means you did not know that the lines are parallel, but based on the corresponding angles being equal, it then makes them to be parallel. And that's what you will then need to do here, right? So you please need to make sure that you understand what this means, right? To prove something is not necessarily what you are required to do. That's a conclusion that you're gonna draw after you prove what makes it to be what we want you to prove. So if I say prove it's a cyclic quad, I'm actually asking you to prove what makes a quadrilateral to be called a cyclic quadrilateral, and then you can claim from there. So that's what you please need to make sure you are clear about. Guys, I want us to take one last ad break. When we come back, we'll then look at other questions that we're going to do, and then you guys will also know for sure that now you understand what we've done. But for now, let's take a quick ad break. I'll be back just now.